You see AI everywhere now, right? It's in self-driving cars, it's creating this mind-blowing art from just a few words. Honestly, it can feel a lot like magic. But have you ever really stopped and wondered, how does it actually think?
Okay, so let's get right into it because the answer is just fascinating. It all comes down to this incredible concept called a neural network. And that right there is the secret brain behind pretty much all of the modern AI you see today. And the wildest part? The core idea isn't from some sci-fi movie. It's inspired by, well, us, by our own messy, amazing biological brains. Just think about it for a second. Your brain has billions of neurons, all firing and connecting and talking to each other. And AI's neural network is just a digital version of that, trying to mimic the same process. And once you really get that basic connection, the entire world of AI starts to make a whole lot more sense.
So let's make this real. Imagine you want to teach an AI to do something that seems simple to us. Tell the difference between a picture of a cat and a picture of a dog. Now, you can't just write a rule like, if it has pointy ears, it's a cat, right? Because, some dogs have pointy ears too. So instead, you have to do what you do with a little kid. You have to show it tons and tons of examples.
This is where the whole structure of the neural network really comes into play. It processes everything in 3 basic stages. First, all the information goes in through what's called the input layer. Then it gets crunched and analyzed in the hidden layers. And finally, the network makes its best guess through the output layer. Simple, right? Senses, thinking, and a guess. So that first part, the input layer, you can think of it like the AI's eyes. Each little neuron or node in this layer is just looking at one tiny piece of the picture. Maybe it's the color of a single pixel or the sharpness of an edge. It's just soaking in all of that raw, unfiltered data. Okay, so from there, all that data flows into the hidden layers. Now this is where the magic really starts to happen. This is the thinking part. Each and every neuron in these layers gets signals, does a quick little calculation, and then decides whether it should fire and pass a new signal on to the next layer. It's like this massive cascading chain of tiny, tiny decisions.
So what makes one connection more important than another? Well, every single one of these connections has something called a weight. Just think of it like a volume knob that controls how strong the signal is. A high weight means, hey, this is super important. A low weight means, not so much. But here's the real kicker. When a network is brand new, all of these knobs are just set to completely random positions. It's basically a newborn digital brain that knows absolutely nothing.
But of course, a brain full of random guesses isn't very useful, is it? The true genius of a neural network, the thing that makes it so powerful, is its ability to learn from its own mistakes. It all happens through this incredible feedback loop.
So after all those tiny calculations have rippled through all of the hidden layers, they finally arrive at the end, the output layer. This layer takes all that processed information and boils it down into one single confident guess. For our cat and dog example, it might spit out something like, okay, based on everything I just saw, I am 92% sure this is a cat. But this is where the real learning starts. So, what happens if the network guessed cat, but the picture was actually a dog? Well, a process called backpropagation kicks in. The network basically gets told, oops, you got that one wrong. A little error signal then travels backward through the entire network, and at every single connection, it slightly adjusts that weight, that little knob we talked about. The connections that led to the wrong answer, they get a little weaker, and the ones that might have led to the right answer, they get a little stronger. It's just a constant process of trial and error, getting a tiny bit smarter with every single mistake it makes. Now, I want you to imagine this happening millions and millions of times, with millions of different images. The network isn't just following rules that a human programmed into it. No way, it's actually discovering its own patterns. It's figuring out that features like whiskers or floppy ears are good predictors of cat or dog. It is literally teaching itself what to look for. So why is this simple idea of learning from mistakes so absolutely revolutionary? It's because when you take this concept and you scale it up, way, way up, you get something called deep learning. And that, my friends, is what changes everything. Its power really comes down to 3 key things. First, just sheer complexity. We're not talking about a couple of layers here. We're talking hundreds, sometimes thousands of layers with millions of neurons. Second is this idea of abstraction.
The first layers might only see basic things like lines and colors, but the next layers combine those into shapes like an eye or a nose. And the layers after that put those together to recognize a whole face. It builds understanding one step at a time. And third, adaptability. This same basic structure can learn from almost anything you throw at it. Images, sound, text, you name it. I mean, we're talking about networks with billions of connections, all fine-tuning themselves automatically. It's this massive, massive scale that allows AI to find these incredibly complex patterns that, honestly, no human being could ever hope to spot on their own. And this incredible power is already reshaping our world. And with it, that brings both massive potential and some really serious questions that we all need to start asking. The impact is already everywhere you look. This is the tech that's behind self-driving cars, it's behind instant language translation on your phone, it's helping discover new medicines, and it's even trying to predict the stock market. It is poised to transform pretty much every industry on the planet. But all of this incredible power creates a totally new kind of challenge. Because these networks learn on their own, their reasoning can become a total black box, sometimes even to the people who built them. So as they get more powerful, as we trust them with more critical tasks, the really big question becomes, how do we make sure these systems that have taught themselves are fair, are unbiased, and are under our control? So, to wrap it all up, if you remember anything, remember this. 1, neural networks are the brains of modern AI. 2, they don't get programmed with rules, they learn from data through a constant cycle of trial and error. And 3, their real, mind-bending power comes from doing this at an unbelievable scale, letting them find patterns that are totally invisible to us.
So the next time you see an AI do something that just seems impossible, remember what's going on under the hood. It's not some unknowable magic. It's just billions of tiny connections, constantly adjusting and learning, all inspired by the most complex and incredible thing we know of, the human brain itself.